Okay, hopefully the last video that we're going to be watching here for this lesson. Now we're going to maybe look at the big ideas between permutations and then combinations. A lot of times, or maybe I should say so far, with permutations, we've used every option that we've had available. Most of the time, though, you're going to have a group of things that you can pick from, but you're not going to use every single option. And so when that happens, we have to use this formula right here. It says we have n objects, but we're only going to take r of them. One way that we say that is NPR, so we know that there's a permutation, but we also realize then that order matters, because with permutations order matters. We just take n factorial and we figure out the difference here, and that's going to go in the bottom factorial. Here's a typical example. 16 actors answer a casting call to try out for the roles as dwarfs in the production of Snow White and the Seven Dwarfs. In how many ways can the director cast those 7 roles? So as we go through this, you're going to have 16 options for that first dwarf, but then only 15 options for the next dwarf, only 14 options for the third dwarf, so on and so forth. But you're only going to pick 7 people. There's going to be, what, 9 people that aren't going to be chosen at all. So as you go through this, you do need to realize that order matters, because if someone is assigned that first dwarf, and then we look at a different situation where maybe they're assigned the fourth dwarf, those are different situations, and we would say that it's a different way that we could cast these characters. So as we set up the formula, there's 16 options, so n is 16. We're only going to choose 7. We plug them into the formula. We get 16 factorial over, in the end, 9 factorial. Simply plug that into your calculator. You would get this many different ways that we could cast that particular production of Snow White. If you're in class, I'll probably go through that just a little bit more. Just make sure you have this stuff written down, and I'll probably have another example that I might show you. If you're on vacation already, as you're going through homework, just make sure that you realize if it's a permutation situation, you're going to use that formula. Okay, combinations. Combinations are a situation where order does not matter. You should have less options. The formula looks very, very similar to what we had up above, but if you notice in the bottom, we add the r factorial. Then that's going to take away some of our options. Typical example, how many 3-person committees can be formed from a group of 7 people? I'm just looking at the group of 3. I don't care what order that they're selected in. So typically you might say, well, I'm going to pick a president, a vice president, and a secretary of a group. And then order matters, because I'm concerned about who is in that top position. The way that I phrase this question, it's a 3-person committee. That group in general is making decisions, and no one is placed higher than anyone else. So this is a combination situation. Again, n would equal 7 here, r is equal to 3. We plug the stuff into the formula that we have. We get this kind of thing. We plug that into our calculator. There's only 35 committees that we could make. So you should expect smaller numbers when you're dealing with combinations. So in summary, permutations order matters. Combination order does not matter. Make sure you know the formulas, what we plug in there, and we'll go through a couple more examples in class if you guys have questions. Last idea here, as I scroll down, ooh, colors. Okay, just a couple of examples for thinking through what is a combination versus a permutation. Example 1, we are selecting a president, vice president, and secretary. In that case, order would matter, so that's got to be a permutation. Question 2, a cook is just choosing 5 potatoes out of 12 to make potato salad. Doesn't really matter what order the potatoes are picked in. We're just worried about having 5 potatoes, so that would be a combination. And example 3, we are making a seating chart for 22 students. So if I have basically all 22 kids sitting in an arrangement, and I say, oh, little Sally and little Mike, you better switch spots. That is a new seating chart. Even though most of the kids are still in the same spot, the order has changed. We say it's a different chart, so that's got to be a permutation. Okay, that is it for videos. Make sure you got everything jotted down, and I'll ask you for some feedback on this in class so you can start thinking about that too. Hope you have a wonderful day.